Please join me in welcoming Donald Leka. Thank you.
So these are exciting times in the geopolitical world as well as the AI world, and the two are intersecting. And because events are moving more quickly in the world today, it's important that graduates coming out of international relations backgrounds, political science backgrounds, have a better understanding of this technology because it's having a direct impact on every event in the world. And it can be utilized, if utilized correctly, to do a better job of predicting the outcomes of proposed policies before we engage in those policies. And that's a really critical element to this presentation. So today we're going to talk about dynamic reasoning models and AI's direct link to the physical world and human decision making. So the founder of AI, John McCarthy, outlined two main lines of research for artificial intelligence. And he coined the term artificial intelligence back in 1958. And he said the first line of research is biological, based on the idea that since humans are intelligent, AI should study humans and imitate their psychology or physiology. And almost all of the investments in AI that you've seen over the last few years, in the last decade, have been really focused there. And the second he outlined was phenomenal, based on studying and formalizing common sense facts about the world and the problems that the world presents to the achievement of goals. And that's what we've been focused on, and we believe that's the critical missing link for the other systems that have been built. And he does talk about the fact that these two approaches do interact and both should eventually succeed. So where did this start? Why did this focus on large language models and trying to, in a sense, mimic human behavior, human psychology? Well, it actually begins with Alan Turing. How many people here have seen the movie, The Imitation Game? Yeah, pretty much everybody. Great movie, right? And really brilliant guy. I mean, just to understand, I mean, he broke the German Enigma code during World War II. It's estimated by historians he reduced the length of the war by about 2 years and saved about 14 million lives. So it's very important to keep that in mind. But a quote that is attributed to him is that a computer would deserve to be called intelligent if it could deceive a human into believing that it was human. And so it's important to understand that that's the root, really the beginning of everything that you guys are experiencing with ChatGPT and every chatbot that you're using today. And he came up with something called the Turing test. And the Turing test essentially said if you put a human being and a computer behind a screen and you ask both questions, at the point at which you cannot distinguish between the two, which is human and which is machine, that's the point that we've attained artificial intelligence. The problem, of course, with that is that behind both that person behind the screen and the computer, behind that is another screen, and behind that screen is someone programming the machine. And so that was not really taken into account, and he was just approaching it from a different perspective. But we've had this obsession of recreating a human being, recreating human intelligence, eventually embodying it in robots, and that's kind of where the focus has been, with kind of the human-centric perspective at the core. But at each generation of the development of AI, and we've seen this with the earliest chatbots in the 60s, so you had Eliza and you had Perry, and those, they always reach a limit. The first is that it operates in a digital environment. So there's no direct connection to the physical world in which we live in which we make decisions, and in which events impact us. The second is it's programmed. So it struggles when there's a novel situation. And in geopolitics, there's always novel situations. There may be similarities with previous events, but there's always new variables in those events. And the third element it struggles with is complexity. So the more complex a situation is, again, you see the deterioration in performance. And this has been in every decade, but most recently, just in June and July of this year, the benchmark test started to come out. And you can see here significant performance drop-offs with COT, which is chain of thought, which is basically a reasoning framework that exists on top of the architecture of LLMs. You can see here significant limitations in handling complex multimodal meaning not just text, but also images and other types of media. And limitations in handling complex multimedia and multi-step reasoning tasks, even with advanced techniques like chain of thought. And there's also tree of thoughts, which also has a similar function, an attempt to try to bring it to life. And finally, you can see here frontier LRMs, these also exist on top of LLMs, face a complete accuracy collapse beyond certain complexities. LRMs have limitations in exact computation, and they fail to use explicit algorithms and reason inconsistently. So these are serious studies that have been done by very serious people, and we've reached that point where, again, AI is bumping into a wall. And it's bumping into a wall because of the three factors I mentioned before. A lack of connection to the physical world, and by that I mean monitoring, basically, monitoring in real time or live what's happening in the physical world through sensors, through video, through audio, observation-based types of data, okay? 2, novel situations, and 3, complexity. So let's return to the second line of research that John McCarthy was talking about. Phenomenal, based on studying and formalizing common sense facts about the world and the problems that the world presents to the achievement of goals. And that's what we have been focused on for the last 7 years in developing this platform. So when you really look at what we're focused on, it's really trying to have a better understanding of the natural world. So the idea is that human beings are not the origin point. We exist in the universe. We are part of the natural world. We make decisions. We evolved out of the natural world. So we're not separate and apart. And the idea of observing it from the limitations, and human beings have all kinds of limitations. There are all kinds of living organisms that have better senses of perception, of vision, sound. They can detect things or sense things that we can't detect. So we already have a very limited framework in terms of how we see the world in which we operate in. So it's very important that both human beings and the artificial intelligence systems that we create have this live link to the physical world. Why? Because you're going to get accurate, much more neutral, much more unbiased data. And one of the big problems with AI is the bias in the data. So the answers you get really reflect the opinions of the papers that are written by experts or just silly posts on social media, and they're a reflection of the events. So that's, I think, really, really critical. And so we've architected it from a different approach. We have focused on, really, you can take the 3 lines down below, natural phenomena and human activity and artificial systems. And we really do consider human activity as part of the natural world. And the reasoning, what we did was we still use verbal reasoning. So this is important. Large language models rely almost entirely on verbal reasoning. It's a corpus of text, everything that's been written by human beings, right? And those are just interpretations of the physical world. So we focused much more on non-verbal reasoning, like sensory reasoning, visual and spatial, and focused in on sign reasoning, so being able to detect signals, comparative reasoning, looking for comparables. Once you have a set of signals that something might occur, you need comparables to give you perspective on what that actually means. And then causal reasoning, looking for the movement of variables to understand from there the possibilities or how variables are moving. Are they moving together in the same direction? Are they moving in opposite directions? Are they unaffected by each other? And then analogical reasoning, looking for similar conditions, events, and objects that form the basis for the forecast. Verbal reasoning is the last part. It's just simply to articulate what has been observed. So we see the verbal part being anchored in that observation-based data. So that essentially frees it from the concept of hallucinations and just the wrong answers that we often get, or incomplete answers, or biased answers that we get when we ask a chatbot a question. Okay. The 2 other areas that we thought were critical was we had to achieve this concept of innate curiosity. So the way we were able to do that is there are these natural data sets in the environment, and so if there's an inadequate amount of information, or the data is inadequate or it's not reliable, the system will automatically go out and say this threshold for reliability has not been reached, and it's going to go out and look for more information. And so that's a type of innate curiosity. The urgency drivers relates to really risk threshold indicators. And if those risk threshold indicators are exceeded, then the search for information is accelerated. So it's rapid succession searches for information. It could be in sequences of seconds. So it's a massive cross-sector data sets that we're capturing. And from that, we can start to look for patterns in the data. And then in terms of, because every situation truly is novel from a data standpoint, there are no two events in the world that are identical. Because there was social unrest in Tunisia, and the factors that were reported were youth unemployment and other factors that existed, that doesn't mean that if the youth unemployment rate is the same level in another country a decade later, when the world has dramatically changed and there's a myriad of other variables, like literally infinite variables that are different, that the same event is going to occur 10 years later. And unfortunately, that's how a lot of the analysis is still done. And that's where a lot of the errors come into play. Okay, so it's very important that you assemble the right set of data sources and the right blend of data sources to get the right result. We focus very much on currency scores, so assessing the recency and timeliness of data. Another big problem with LLMs is that they're focused on historical data. So it's historical data. And from our standpoint, we want to get as close to the present as possible in that observation, okay? And so that's one of the key elements. Veracity score, the reliability of the sources, that's obviously critical. Localization score, we have found that when you pull data from hyper-localized sources, it's much more reliable than narrative-driven news that you see, regardless of what the political perspective is. There is a theme, there's an agenda, and there's omission of information that is critical to give you perspective on the events, okay? Sector blend scores, so I mean, if you're looking at rising energy prices or declining energy prices, there's so many variables that would affect that globally. So cross-sector analysis is absolutely critical at all times, and siloed analysis is going to limit your understanding of those events. Okay? And multimodality, again, getting away from text. Again, almost everything out there now is 99% text analysis. So this is an example of how the system literally generates, once it identifies that thresholds have been exceeded and that there's the probability of an event, it automatically spins up 12 candidate data source networks. And out of those 12 networks, it quickly assesses the currency of the data, the veracity of the data, and the depth and analysis. And that can be done in a matter of seconds. And so we go from 12 candidates to 3 candidates. Of the remaining 3 candidates, we do a second loop analysis to see how accurate the forecasts are. And that can be done in seconds and minutes as well. It takes a little bit longer because we have to test that more. And then you get to the best performing candidate selected. This whole process is automated. Okay, that's really important to understand. The user doesn't do anything. Everything from the beginning, the identification of the probable event, the thresholds that are exceeded, the system kicking into innate curiosity, determining if it's urgent or not, and spinning up these candidate networks. All of that is automated, and you don't have to do anything. So it's literally doing that. And then the reasoning process kicks in. So you can see verbal, we still use it, but you see other things here. So we start with signals, and basically, as you can see over here, if the cluster of signals is not enough, let's say it's less than 0.5, the system continues to search. That's the innate curiosity we were talking about before. If the event signals exceed, let's say 0.5, and those are dynamic and they can be changed under different conditions, there's a handoff to comparative reasoning. Why? To give you perspective. What does this data mean? It doesn't really mean anything. It could sound really terrible without a comparable, or it could sound great without a comparable. So comparables, and you need the right comparables, right? So you can't be comparing, let's say, the United States performance in an area to Iceland. Iceland has a population of 250,000 people, right? So these are false types of comparisons that lead to bad conclusions or inaccurate conclusions of what the severity or the significance of an event might be. Assuming you have those, there's a handoff to causal reasoning, you can see that. And then you look for the cause and effect, then hand off to analogical reasoning, looking for the similarities, generating the forecast. And then verbal is just used to express it in words. But those words are anchored in facts. They're anchored in data, currency of data, veracity of data, localized data, cross-sector data to give you the full perspective of the events that are occurring. Assuming that you only have verbal signals, well, this is a flexible system, just as living organisms will solve problems in different ways. So if the signals are all verbal, and maybe it's just human observations, but we can't verify that with satellites or sensors, there might be a handoff to verbal reasoning right in the analytical process until that's achieved, and then hand off to comparative, and then to causal, then analogical. So it could go any way to solve the problem, and that's autonomous as well. So it goes through that process. Once an event occurs that was forecast by the system, that also dynamically alters the threshold. So those thresholds for an event might go up slightly or go down slightly. Even those, the only manual input is just the initial input of the thresholds. After that, the whole system is dynamic and functioning and learning on its own. I always have fun with this. So we didn't want to pick the great apes or dolphins or crows, right? All the stuff you read about how smart they are. We picked bacteria. So bacteria engages in sign reasoning. The octopus, they're actually smart. Causal reasoning. The medicinal leech, that's kind of a funny one, right? So comparative reasoning, and you can see the Polistis wasps engaging in analogical reasoning. So certainly for sign reasoning, almost every living organism engages in sign reasoning of some sort, okay, some form. Causal reasoning, also very common. Comparative reasoning, also very common. And analogical, not as common, but it is more widespread than you would think. So it's pretty interesting to see. So what is the role of verbal reasoning in our model? So we're talking about basically by improving the currency, veracity, and multimodality of cross-sector data for analysis. LDRMs reduce the noise and bias inherent in verbal reasoning and reweight verbal reasoning processes in relation to sign, comparative, causal, and analogical reasoning. So that really is where we see its place. It has its place, but it's not the only thing. And that's why it's important to not be only reliant on that. The reasoning methodology, so one of the first things our system does, because it can, and a human being can't do this, is finding the common elements across the different data maps of similar events. It could do that really fast. Then there's a process of elimination, obviously, of non-common elements, and a process of elimination of insignificant elements, elements with values closest to zero. This also reduces the size of the maps, it accelerates the speed of the analysis, okay? And it reduces the cost, which is critical, because the cost to run a system like this is extraordinary. If you were to run it every day, all the time, monitoring the whole world. And so then you can see the more advanced reasoning elements kick in. And here you can see kind of that dynamic observation-driven inquiry, so you can see the urgent response data sweeps. We're also doing geoscans, sector scans. This is where it gets interesting, time inflections. So we're taking geopolitical events and basically inserting those into how it's going to affect equities or digital assets like Bitcoin or stablecoin, USDT and USDC, commodities, fixed assets, portfolios. So we have a whole little use case we'll show you on bonds and corporate bonds in relation and the credit spreads with US Treasuries, corporate M&A, supply chain junctures, and market events. Also, the ability to customize these parameters as well is critical. So if you're working on a specific project, you can also manually customize that. Multimodal search queries, very important. So this is not text heavy or text dominant or almost entirely text. Cross-jurisdiction search queries. And then, of course, you could do what you do with ChatGPT. You could just ask it questions and it'll give you responses. So let's walk through 3 use cases. So one, let's talk about the current discussions between Russia and Ukraine and the United States and Europe regarding a potential peace agreement. So if you look over on the right side, you see the propositional logic that the system lays over this layer of logic. Basically consists of propositional logic and data set theory. Why we chose data set theory is because the world actually has these natural data sets, including our behavior. So it kind of just flows in these natural streams of data. So that was just a really good way to logically organize that. The propositional logic was also critical to be able to link everything together. So you can see three scenarios here. A full peace agreement is reached. There's a signing and normalization, and economic conditions normalize, right? And so you can see what the impacts are when those occur on different assets. You can see it again with a limited peace agreement. So in the case of a limited peace agreement, the uncertainty is still there, the sanctions are still there, and so things just don't normalize and the economic situation remains static, and peace talks fail. Obviously, the same is the case. So here, if you look down here at the set theory, you can see here, so this is Russia, so you have still a state of war. So those are equities, right? You have, bonds, you have, all the different currencies and so on that you can see here. If there is peace agreement, you see the addition of foreign equity. So Russians would have access to the foreign equity market, which they don't have access today, okay? For Ukraine, it's a very different situation. If there's a peace agreement, you're going to see a movement back into Ukrainian equities, Ukrainian government bonds. Bitcoin will remain, stable coins will remain, and of course foreign equity investments. So there'll be this whole rebuilding, and that's why we can reference that up here, the reconstruction of Ukraine. When that happens, there's a huge economic opportunity. It's going to have a massive impact, obviously, on Ukraine or anybody who wants to invest in Ukraine. This is dynamic, so those probabilities for a peace agreement are dynamic. So you can see greater than 0.51, there's a full peace agreement, greater than 0.37, that there's a limited peace agreement, greater than 0.12, that peace talks fail. So, and these are dynamic, they fluctuate daily. It could be a statement a government leader makes, a post, it could be anything that drives that. Okay, let's look at Armenia and Azerbaijan. Who's aware of this agreement between these two countries? Anybody? Very good. 2, 3, good. So this is actually a big deal. The US has had very limited influence in the South Caucasus region. It's been dominated by Russia and Iran. And this agreement basically gave the United States a 99-year lease for this very strategically valuable trade corridor. And so if this agreement works, everyone's going to benefit. The Armenians are going to benefit, the Azerbaijanis are going to benefit, the United States is going to benefit, and so on. Regional destabilization, the second scenario, that's if the Russians and the Iranians try to destabilize this agreement, which is very likely that they will. So will they succeed or not? Well, if they do succeed, obviously the benefits will be much more limited. And then a mixed outcome, which is generally what happens in international relations, right? Things don't work out exactly the way you intend or hope for. And you can see the impacts there. But it's, again, all of these metrics are dynamic, okay? And then the third scenario, we can talk here about the bond market credit spreads. So basically, what we're looking at here is how certain events, like tariffs, tariff implementations, trade disputes, escalating regional conflicts, geopolitical fragmentation, rising financial instability, and credit market stress. So we take those types of variables, and we can see here in scenario number 1, confluence of cross-sector events substantially widens credit spread. So if all of those things happen, you're going to see instability, and you're going to see these credit spreads widen. If only some of these things happen, for example, if just the trade war disputes continue, they'll widen, but less so, right? And here you can see regional conflicts widens credit spread. So that's the regional conflicts, trade war disputes, whatever it might be. It's very important to understand that you can get very, very micro with this. So you can see the specific impacts here on the different variables. So you can see the different bonds that are impacted, whether it's high yield bonds, which are really junk bonds, obviously, a nice way of saying it. And then you have the corporate, you have the high quality corporate bonds.
Well, it's 1 o'clock. Let's join me in thanking.
Thanks, guys.
Thank you for coming. Thank you.